Mud Fossil University, Roger once again, and with some corrections and a little bit of an update on the Aether. And the other day I did this one. Aether fields finally photoed and are exactly as expected. Aether is spelled with an A-E. Now, and they are exactly as expected. And now, there's more to this story, though. As I went on a little deeper in there, I made some more associations and some more, experiments that proved other things as well. And I am now of the opinion that molecules and elements may literally be compressible and may literally be able to force electrons into them and to remove negative particles away from them in such a manner as to affect their weight and so forth, and actually lead to anti-gravity. So it's pretty involved. This was the beginning part that showed all about the Aether, and now we're going to go into a little more details or to show about electron flooding and sonoluminescence, the whole shooting match, because it all has to be explained, every single bit of it, in order for any of it to work at all. And it is all explained now, as far as I'm concerned. I mean, there are things that need, honing in, but it makes more sense than anything else that's been spoken of. And I'll try to break it down as simply as I can. All right? Good luck. Okay, this is Latham's Crazy Machines. Now, I'm going to try to make this as simple as I can make it. I am saying this is virtually an atom. There's your nucleus. There's your electron. Now, because nucleuses and electrons have both positive and negative. There is no such thing as a negative only, and no such thing as a positive only. Everything is excessively negative, but it also is positive. So, what does that mean? Everything, well, let me put it this way. Everything repels everything else because everything is excessively negative. Excessively negative. This is also positive, but you always have at least as much protons as neutrons, and neutrons, I am saying, are negative. So what you end up with, and the neutrons are bigger than the protons, they say that, by a tiny, tiny, tiny little bit, and that tiny, tiny, tiny little bit is enough to make this more negative than it is positive. So it's highly positive, which attracts everything negative, and light is highly negative. And it also is more negative than it is positive, so it only allows the negatives to come to a certain distance, which we're going to call a quantum distance. So, let's step back again and think about this. The nucleus is both positive and negative. The positive attracts all the negatives that are anywhere, which everything has some negativity to it. So the positive attracts the negative parts. But the negative excessiveness says, okay, you can come over here, but you can only stay so close. And here, watch what happens. This is what it's going to show right now. Alright, so he's going to go ahead and do this. And it's Latham's Crazy Machines. Nicely done. Boom, there it goes. That's the quantum distance. Now, what does that mean? It means that this electron is supposed to stay right there. That's it. When it's sitting there and everything's fine, it's in a nice, no extra heat's coming in, no cold is being pulled out. It is sitting there just happy as it can be, just like that. But what happens when you put heat in here, it starts to shake because somebody else is trying to force more of these in. That's what heat is. I'm forcing more of those, where's this going to go? He's going to push somebody. That's going to push somebody else, push somebody else. That's heat. If it's cold, it's drawing these out so quick that they're trying to pull electrons from everywhere else, which is from everybody else's heat. So they're pulling electrons in to try to replace what is being thrown out of here because it's cold, it's being sucked out of here to warm something else up. I mean, that's how that works. Now, watch the way it goes. He's going to shake it, and it stays there. It wants to be right there and in between these two little ones. It'll stay there until he starts really shaking it. You see it? Now, right now, he's creating what you would call heat. That's heat. That's heat. The whole thing is shaking. Now, same Tesla said this long ago. He said everything is vibration, and it is. And additionally, everything is ether. The whole universe is filled with ether. That is also correct. The ancients said this. And the ether is nothing more than these. They're these electron particles, the smallest, tiniest particles. And they are everything. And you can see them. You know they're there because they are seen in the magnetic lines of flux around magnets and electrical circuits. When you put these iron filings, they polarize into that. Now, they're not polarizing for no reason at all. There's ether there, and I can show you in our light experiments the actual polar magnetic field of these particles, these ether particles. This is all brand new research, and I'll show you that in a second. But watch what's happening now. The shaking is heat. Now, that thing will eventually fly away, and that is called light. So it's shaking, shaking, shaking. I'm hot, I gotta get out of here. I gotta get out, I gotta go. And it really wants to stay here. Boom, there it goes, that's light. Okay, so we got heat and light. Now I'm going to show you what the ether is, which that's what that's grabbing onto. That particle by is ether. The whole universe is filled with these tiny little particles of ether. That's what magnets effect, is those tiny little particles, and they drag things in with those particles. Alright, I have videos on all this, so I'm going to run through them real quick, but you can go into Mud Fossil University, see videos very deep on all of this. That is a single disc from a pulsed red laser, and all this little stuff in the background is what I am saying is ether, and they are magnetic particles that are the same as light, only they are light that is just lazy, hanging around, not accelerated from a laser source or from any other source. It's the background of everything, and it is it's outer space too, because this is exactly the same thing that comes from the sun and from every other electron source. Those are electron sources. Right, you saw the disk before. Now the disk is being forced through a Venturi accelerator, two metal drums that have curvature, and they force this disk it has to accelerate, and it has to compress, and it turns chaotic and turns white and creates a reverse magnetic field. The magnetic field you see coming through the air is literally the ether being polarized as that light particle pierces the air, and I'll show you an example of that. Alright, this is a very good shot of what I believe light is, and light is a particle, and it came through the accelerator here, and I believe that is the actual particle. Now, this is a theory in progress, so this is nothing I have locked in stone or ever will probably, but this is what I originally thought was light was coming out like this, spinning, and we were catching a strobe of the particle, but it was really in this spinning disk. But that is not the case now. I don't believe that whatsoever. I thought the particle was out here. It's not. It's in the center, and that is the particle. Now, so what are these rings? That is polarized ether. Alright, that's polarized ether. What does that mean, polarized ether? That means that these little dots are the magnetic particles that are in the air that you can't see, but they surround everything, and they give you static electricity on you and all of that stuff. They are in everything, and they are the radiating source of light, really. When you turn a light on and it sort of glows, that is what is glowing, is the ether. But you can't see it in this configuration. It's because it's a laser, and because of the certain increased velocity of the light, and you can easily accelerate light. We did it, and I think I showed you the light acceleration going through the Venturi. It turns white and creates tremendous amounts of magnetic radiation fields. Now, and this is the same exact identical field that a wire makes, you know. If you put a wire straight through here and you turn on a current, you would see the same field set up around. It's called the right-hand rule. They come right around this way if the electricity's going this way. So if the electricity's going this way, these things are wrapping around that particle as it moves through space. That's the nature of magnetic fields, and these dots are the manifestation of that magnetic particle. And you see, as it first leaves the accelerator, it has a very high intensity, then it slows down, slows down. Now, what did we see here? You were seeing some pretty high-powered magnetic particles here. As it gets out here, they don't seem to have any, that kind of, they don't have that sort of intensity of the difference of change of color. When you see the change in color, that's power, no power, power, no power. So it's plus, minus, plus, minus, plus, minus, that type of thing. And that is polarizing the magnetic field. If that was iron filings, you'd see the same thing. You'd see the exact same thing. These are the discs coming out of the accelerator, and if you look at these, every little one of these little spikes is heading out to one of these discs. And what it does is at the tip of that particle, you create these magnetic fields. Those are the magnetic fields that we're seeing. By the way, that's an extremely high energy magnetic particle that came through here that's going to impact with one of these, and I'll show you what will happen. It'll divide itself. These are literally light particles. The particle is coming through here, the field is set up around it, and that's what glows for us in space. This is that white particle that I showed you coming through that's extremely high powered. It impacts, and these of course are the magnetic fields that surround the particle. Now why this has no big field around it, I can't tell you all of the characteristics here. It seems the smaller the lower speed of the particle, the bigger the field, the more these lines. I don't know why that is. But this one here, they sort of crush. I don't know. I can't explain that. However, I can see what I see, and you can see what you see. And this, again, this is an exploratory mission. This is not so, oh, here's I got everything all figured out. No, that's not what I'm saying. I'm saying, look at this. What do you think it is? Here's what I'm seeing. I'm seeing an energized particle that was white coming through an accelerator, which I'm sure the light is accelerating. It comes through high energy. I can see that. It impacts with this disc. I can see that. It has the same architecture as these discs. I can see that. And it is now stepping down to become one of these discs. I can see that. And I can see this is a little light trumpet, which I call that, which is issuing from this impact. Now, why? I don't know. Is that a particle? I would have to assume it is. Because I'm assuming these are particles. Maybe I'm wrong. Maybe they're not particles. Maybe I'm totally in left field. But I'm assuming these disks represent a particle creating a magnetic field surrounding it as it flies through space in an accelerated state, more like electricity. Now, what does that mean? That means that we're visibly seeing the field that surrounds the particle as it comes. This one obviously is different than these. It's obviously different. And they came through the accelerator, and I'm saying it's more energetic. That's all I can say. And I'm saying that is a piece of energy. So if these are light particles, they are supposedly the tiniest particles that exist. You know, they talk about neutrinos. I don't even know if they know what a neutrino is, but they might be these. I don't know. I have no clue. But if they're talking about the tiniest particles that exist, that's tinier. So I'm saying if that's a particle, it's tinier than the tiniest particles that are supposed to exist, which are electrons, which I'm saying are electrons. You figure it out. I'm just telling you what I'm seeing, and you have to see what you see, and then just help me figure it out. All right, one more time, now that you're into this a little bit. There's the disc that was coming, and it's a nice little rounded disc. Well, not when it starts to hit this venturi, which is these two round metal cylinders with curves, it has to accelerate. It's a venturi. In a car, I mean, there is no option for it. So, and light really is more of a liquid than it is anything else. So, then this impact creates this enormous reverse interference in the ether. You see it? That's a reverse interference. You see all the lights that they're all lighting up here, and then you have all your magnetic polarized ether. That's what it is. And normally they'd be coming this way. You'd be seeing them in this direction. So anyway, once it hits there, it's accelerating. We can see that it's turning white. That shows that it's an increase of temperature, or an increase of energy. Let's put it that way. And it is, I believe, an increase of temperature. As it steps down, you can almost see an absolute break here. If you look there, you just cast your eyes on that. It's completely white, and glowy white, too. That's not a standard white. That is a glowy white. That means that it's up in the very extreme end of the visible light spectrum. You know, with all kinds of different frequencies. And we'll see it come out of there. I call it the rainbow shower. It comes out here, and then it steps down. What does it do when it steps down? You see these little, you see them? They're almost like gunshots. That is what makes the pattern that they claim is the wave interference pattern. This is the pattern. You see it? Boom, boom, boom. You can't miss it. Well, I don't know if this thing might be a little bright here to see that, but that is what's making your pattern, and I will show you that pattern on a back plate. So, what did we just see in this one single picture? We saw light coming through, accelerated through a venturi. We see that it increased in power and speed. We see that it has stepped down in a quantum state. We see that it is creating literal patterns of a screw-like nature, which, hitting a back plate, I will show you what it represents. Alright, here's exactly what it represents. You saw it coming through the accelerator. It's making this pattern. Well, that pattern is what you're seeing here. And that is what they see through the slit, through the single slit. They're seeing this sort of a pattern. That is all they're seeing. And they think it's a wave. It has to be coming through in a wave, and it's a particle sometimes, a wave sometimes, it's nothing sometimes it's something. It is all nonsense. Duality is insanity. It really is. It's just unbelievable that they can go something, and then they go and talk about coming through space. Now let me show you that. That is where we have to get way away from Einstein and run quickly, because he broke science for 100 years. I have nothing against Albert, but everybody got on their knees. As soon as he said, "Oh, c squared," they said, "Oh, what a huge number." Well, it had nothing to do with anything. If Einstein was right, that c squared never changes, because it's the speed of light never changes. So it's like saying times 1. It's a meaningless number, really. And E equals mc squared is meaningless if light has no mass, because if it has no mass, it has no energy. So the whole thing is ridiculous. No mass means there's no energy, and we know light has energy. So I'm going to show you another thing that's silly. All right, here it is right here. If the sun is putting out energy that hits us and warms us and turns on the lights and can create electricity and everything, it's got to be something between here and here, but they think it's nothing. Of course it's something. It is ether. It's the electronic particles that are the ether. They are the particles that bump into the particles that surround molecules. In space, there's only ether. The big chunks come down and they congeal around planets and so forth. You might have the space station out here going around. That's fine. That gets hit and that warms up and does all the things and lights up and all the things that matter would interact with light. But when there's nothing for it to hit out here, it is all negative particles coming away from the sun, spinning down towards Earth. They want to connect with the positiveness of complete matter, which has nucleuses, the positive nucleuses. So they're looking to try to hit positiveness. In space, they stay away from each other, so you don't see them. They are there as energy and matter. They're dark. They're dark energy and dark matter. That's where the stuff is they're looking for. And it does coalesce in areas where there is high intensity of electronic emissions, which are from solar masses and those kind of things that shoot out rays of light. So yes, there are clusters of mass and matter throughout the universe that surround galaxies and have been left in trails from galaxies, whatever it is. But primarily, you are open space out here. There's nothing here really for it to interact with. So it's just scooting through space waiting for something to hit. That's what light is. It's dark energy, dark matter, and as it comes through, it hits here and turns it into high energy light. We can see different high energy colors and everything because you're getting a high energy source. From the moon, you're getting a low energy source because it's a re-radiated light. So this light comes out, bounces off of here, shoots back, and you can't get the bright colors because you can't excite the electrons strong enough. And we're going to go through that now. All right, remember now, this is just a happy little disc coming through air, pulsed red laser. That is the background glow of the polarized ether, which that is too. And that's just non-molested heading through the air all by itself. All right, you remember this. That same wave turns into this high energy radiation. Now this is the high energy radiation coming out of that Venturi, and as it steps down, it changes to a lower color, until it reforms itself back into its red pattern. And once again, here it is coming out of the accelerator. These are the particles. These are the fields they set up. That's the polarity of the ether particles. These are different colors, as you can see, and different densities. That means they're of different intensities and frequencies of light. That one is in an extremely agitated high energy state. And they will sort of cut over against each other as they come through. But primarily they make that sort of pattern that I showed that ends up being the screw pattern on the back wall. And these are the particles, literally, that are seen after the accelerator trailing off for 2 waves. This is a little better shot. That's the accelerator. They come out high energy, all blurred out. Then they step down to a little, see how they have white and dark and then white? Then they do this, whatever's going on there. They look like the old atomic symbols. And I think that might be a torus, and it would work on capacitive reactance and inductive reactance. So one of them chokes on the neck is the inductive reactance. When it tries to force itself through the neck, that creates a reverse magnetic field that opposes that current up to 10 times the forward motion. That forces it back into a capacitive area, the bulk of the torus, the big fat looking area. Then it tries to go back through the other neck, and it would be oscillate back and forth. That's only a guess. It shows up for 2 waves, and then it steps down to this. Now see, before it was white and black and white, and then it's black and white and black. It was like an Oreo upside down or something. Alright, this is coming out of the accelerator. That's the actual particle, and that is the wave that it's setting up. And you can see it compresses. There's 5 different waves here, and they're spinning out through here, accelerated, and then they are compressing here. And strangely enough, Harvard did the same thing. We sent them this long ago, but we saw this You see, that's the stuff that I just showed you. Ours, 5 of them. They're showing this exact same pattern. I don't know what they were trying to prove here, but it's very, very similar. So it's just strange that they have the identical same thing. You know, they're going through a grid venturi. I don't think they understand. Well, I don't know what they're doing, but they're trying to strip atoms off or something, but they're getting the same pattern we're getting because they went through a venturi, which is this restriction through this grid. Theirs is all blurry, but ours is very, very refined because it's through a single slit instead of a grid. Appears to me the ancients knew about this stuff too. Alright, remember this, don't forget this. This is really important. This is the quantum effect of electrons coming up to a core. Shaking it is heat, and shaking so violently that it throws it off into space is what light is. And the reason light is seen, alright, the reason light is seen is because it's shooting those electrons into space from some interaction. Now, what is the interaction? It could be one of these things, and I'll show you how this works in a second. I'm going to do this with toys, and you're going to understand how this whole thing is. If I force that in so hard that it tried to force itself back out, it might fly out of there. Or if I smashed all of this stuff together, if there was thousands and thousands of these and millions of these all over, and they were all crushed together like this, and then they would spring out and they would overheat because they're forced into this mass, and you could see how the white came from the red we had before. That means it's heating up. The same thing will happen here, and I'm going to show you that in another toy. Alright, it's not really a toy. This is Bushcraft Fires, and he sells these. www.bushcrafttools.com. Now watch what happens here. I have one here. It's an aluminum one. I have one here. Now I'll show this in a minute, and I'll try to demonstrate why this happens. And what he has here is this tube is going to come down and crush the air that's in here. There's nothing more than air in there. There's nothing fancy. It's just air. But he has a combustible, very combustible piece of carbon fiber here, and carbon fibers set up correctly will combust easily. And you know what else combusts like crazy is lint from a dryer. Cotton rags, when you get the lint out of there, forget about it. You hit that with a spark and it's like unbelievable combustion. Now, he's going to force this down, and all he's doing is compressing the air. Well, what do you think is going to happen? He's going to start it on fire. That's how that's going to start on fire. Now watch what happens here. I'll open this up. So don't forget, now this is transparent fire piston, and this is by Bushcraft Fires. And here it goes. He's going to slam it so hard. There he is. It's starting on fire. Now, what does that mean? All he did was force air to crush. And so what happened then? Well, we got a lot of heat came out of here, obviously, because it started a fire. So let's explore that reason. Alright, these are the slow-mo guys, excellent slow-mo guys. Underwater explosion at 120,000 frames per second. That is unbelievable. Now, these guys are the best. You saw that compression of the fire piston, where this thing comes down and pushes and forces the air in there so hard that it explodes and creates a fire. Now, what does that mean? It forced those electrons to be so tightly together that they interacted in such a manner to almost be literally electricity. And I am going to show you this in reverse. Now, what's going to happen here is they're going to blow off a firecracker underwater. Now, the firecracker has a certain amount of outward expansion it is going to do. That's just how it works. It explodes. Now, what does that mean? Well, it's in a cavity of water, which the cavity of water is compacted upon itself, and water is a highly polar molecule, highly polar. So when that explodes, it starts to throw that water away from the explosion. Well, the explosion is violent enough to exceed the amount of material that is in the firecracker chemistry, because it only can add so much to that water. So what it does is it opens up a cavity in the water. When that cavity opens up, it'll start exceeding the chemistry, and it will actually put a fabric in time. It'll crack the whole a fabric in space. And so you'll end up with chemistry out here, and then a crack in space all the way surrounding it. A literal crack in space, where there is nothing exists. And that will fill up with electrons. That's what I'm going to show you. Remember what I'm saying. That will explode, and around it, at the edge of the shock wave, it'll continue to expand out here. And when it does, that whole expanse will fill with electrons, literally electricity. And when it comes back, that electricity will have nowhere to go, and it will explode with unbelievable power. And they say it creates millions and millions of volts of electricity. I mean, of degrees of temperature, millions of degrees of temperature. And I'll show you what they say. And I haven't measured it, but that's what they say. Now let's watch this, and you're going to see what happens to this. This is fabulous. So this is, there it goes, it's exploding. Now, they have two ways of seeing this. This sees way inside. Or wait a minute, let's see. No, this sees inside, and this sees the outside side. But I'm going to stop it in a second. You see these little particles glowing? Those are actual electrons that are starting to fill up the space that surrounds the concussion. And this whole area will fill up with these particles, and then as it collapses, they will boil because they have nowhere to go. So just keep your eye on it. Here it goes. It's still expanding. Still, see the particles showing up, these colors? You see the little particles showing up? Those are electrons. Those are electrons. And they're filling this space. And the space has nowhere now, because this is the chemistry. Now it's coming back down. Watch this boil. You see that? That is boiling. That's boiling. See that boiling right there? And here it goes. Now there's going to be so much explosion. Watch. Boom! It went off. Now we're seeing the outside of the ball, because we're seeing how poof, it's out. Now, it's done. The explosion is over. That only took less than 1/100 of a second to do that whole thing. Now, they're going to go on about this, but what I want to show you is what happens at the surface of the water, because that's where your major concussion happens. All right, here it goes. There's the low one. There's the small one go off. Now, as it collapses, watch the colors come out too. Then you're going to get your real major. Now it's collapsing. Boom, there it goes. That's where you have that major collapse. Because the first one went off, it started to come down. Now it's going into outer space. Okay, now don't forget, you see this? These guys were outside doing this. This is outside, so they're getting the sunlight shining in on this. And that is the source of these electrons. That is what I'm saying, is because they're outside. Now, if they did this inside, I don't think they would get the same type of light explosion. And the light explosion, I'm saying, you see, this is the firecrackers done. Let's just stop this for 1 second, because you saw it expanded from the firecracker. Well, this is inside. We're still seeing the light coming out from the inside, but we can see it's gone. It's done from the inside. It's the firecracker explosion's over, so there should be no more light really to speak of. But watch what does happen. All right, it's going on, and it's still going out. And this light now is going to be a light on the inside that starts glowing. You see this? Watch. Because now the inside glows from the collapse. Not the outside like from before. Not a collapse. Look at that. That is so intense from this crushing itself back down. And that is a boiling ball of electricity. That's what it is. And when it goes off with the intensity of a flash bulb. Watch. Boom. Done. And that was 120,000 frames per second, so that's pretty fast. Alright, so that's what I wanted you to take off from that one. Okay, they're going to manipulate a bubble that's suspended within the water, within a certain type of solution water, that is going to expand it up, and they have to get it to a certain area, and then it goes a little more than that, and that's when they get the
it moves sporadically. Raising it further will dramatically decrease the radius of the bubble's movement, so then it appears
Just
fuzzy,
shaking it with,
and the bubble will grow larger.
with sound.
Slight increases of the sound level will put the bubble in a small and stable state, but too large of an increase will result in the bubble dissolving instantly. For sonoluminescence to occur, the sound level must be in the threshold between these two states. Once the bubble is in the correct state, it will start expanding. When it has reached its maximum size, the bubble collapses at an acceleration theoretically predicted to be larger than that of a black hole collapse.
That was exactly what we saw with the firecracker. It expanded to a certain size, and then above that is where it creates this enormous amount of electrons coming in.
Collapse. At the bubble's minimum radius, 500,000 photons of light are emitted in a flash of light that can be seen for shorter than 50 picoseconds, or 50 millionths of a millionth of a second. During this period, the interior of the bubble is twice as hot as the surface of the sun. Then, the bubble size rapidly fluctuates up and down until it reaches the small and stable state that it once started with. As these cycles occur incredibly fast under the correct circumstances, 40,000 flashes of light can be generated per second, which gives the bubble an appearance of a tiny, unblinking light and can be seen with the naked eye, despite the bubble itself being microscopic. More importantly, sonoluminescence can be used in sonofusion, which is the use of a collapsing bubble's power to achieve uncommon states of matter, or simply put, nuclear fusion in sonoluminescing bubbles. However, it still stands that the temperature is not hot enough for nuclear fusion to occur on a big enough scale. But as scientists from colleges and universities the world renowned study sonoluminescence to this day, breakthroughs are bound to happen, and nuclear fusion may soon be achieved through sonofusion. With the accessibility and ease of researching sonoluminescence, it is fair to say that there are plenty of open doors for discovery. For years, bubbles have amused us. These little pockets of air rise in solution.
Okay, that is about sonoluminescence. Now, I'm going to show you why I say sonoluminescence, I believe, is highly affected by the light source that is around it. In other words, the sunlight. And I'll show you why I can say that statement. Alright, this is the best example of electron flooding. You see his shadow, and watch the pulses come. I know I've shown this before, but it's hard to see this in. See him it keeps stepping away, stepping away, stepping away. There was light here, as the shadow moves away, the light fills it in. That's all. You see it? The light fills in wherever the shadow moves away, and they are not reflections. So I'm saying those are filled with electrons. Now let's go see how that would happen on the board. Alright, I was going to do the whole thing here all in one shot, but I'll tell you, your brain is probably cooking because of mayonnaise. I can tell you that right now. So we're going to leave it at this, but I want you to understand what you have just seen about all of the different conditions and the electrons and the flow of electricity and so forth. That is all to do with electrons and ether and the light coming from the sun and how electricity flows. It's not necessarily totally into the nuclear portion of matter. It's more to do with the electronic fields and the magnetic fields and the flow of electricity, hot and cold, the movements of such. Now, speaking of hot and cold, I will go over this later, but here's the takeaway. Electricity, heat, hot, cold, light is nothing more than electrons flowing through ether. That's all it is electrons flowing through ether. And ether is everywhere. It is everywhere. It's everywhere. It's all around the planet. It's all within structures. It's everywhere. It's everywhere. It's everywhere. inside of all this stuff. There's ether everywhere inside of that. Some of it's mobile, some of it isn't. But these are the ether particles. They're light. When electricity flows through the air, I mean through a wire or through the air, it creates magnetic fields. You see them with the iron filings as the magnetic lines of flux. You know, on the tables they put a magnet and you see them all go around it. What that is doing is setting it up on those magnetic lines of flux. The flux has to be there. That's the polarizing effect. They go positive, negative, positive, negative. In the air, they do the same thing. But you can't throw the filings up in the air and make them collect up there. I don't think. I haven't tried it. But you could throw them on a table. You put that thing through the table and you run electricity down and you throw a wire. It's going to show up on those magnetic lines of flux. And what I show in the air is a plus, minus, plus, minus, plus, minus, all the way around the particle flowing through the air. It's identical. It's identical. So there's a lot to go over here. But I have a feeling. I did a lot of things, but one of the things I did was I worked in the semiconductor industry. And semiconductors work on something called PN junctions, primarily. And all transistors basically do. And they have a base, and then they have a collector and an emitter. And there's a whole batch of electricity sitting here waiting. And let's say it's all positives. In other words, it wants to accept electrons through there. Well, the base is saying, no. I'm putting positive on this base right here. So you positive guys, you got to stay over there. You can't come through here because I am reverse biasing you. Now, when and it's just a little tiny thing. It doesn't take much. It's called a junction, positive negative junction. There's PNPs and there's NPNs. It depends on which the center separator polarity is. So let's go with NPN. So you got a whole bunch of negatives sitting out there. You got a positive base here, but I'm calling it negative for now. So I'm keeping negatives away. So I say, okay, I'm a negative base here, a little flat, like wire almost, like a little flat plate. Like this here, just a flat plate in between the positives and the negatives. So it says, all right, I'm positive now. You guys can't come through here. All right, and it's a good thing over here says, well, we really would like to get some positives. No, we got positive here. You cannot come through. Well, then all of a sudden I say, all right, I'm going to go negative. As soon as I go negative, that little tiny strip in between says, okay, you guys can come through here. That's what's called forward bias. And then those positives go to where the negatives want. I mean, shoom, they go through there. That's a transistor. It turned on electricity. Just like it turned on electricity or a light bulb or a motor or a TV, whatever it is. So that's how that works. It's forward bias on the transistor or the base. Now, I can't see why there couldn't be an insulation barrier with a forward and a reverse bias on it. Because heat is nothing more than electricity. It's nothing more than electrons. If I said you electrons can't come through here, I am stopping heat from leaving. The electrons are buzzing over here. They're hot. I want to get out of here. I want to get out of here. And the cold says, yeah, we'd like to have you guys. Come on. So they move into where the cold is. But and they're electrons. These want electrons. These have excess electrons. If I could put a strip down the middle and say, okay, this is the base between these two. And I'm going to polarize you and say you are now negative base. That means these negative electrons, who are the heat, can't get through there. They can't get through to where the cold is. That's what I would suspect would happen. If you could put a barrier between, like in a window or something, and just polarize the thing somehow with a film that said, because they do that with liquid crystal displays, of black displays. That's all they do is they polarize a crystal in there, and it flips, and it presents a black face rather than a clear face, something like that. I forget how it works now. It works that way, but I can't remember the details. Anyway, and now, getting to this point, there's more to the story, a lot more, because I think that cold and heat are almost the same thing as molecular expansion and contraction. And you can see it. I mean, things swell up when they get hot. They contract when they get cold. And then you have the magnetic levitation. It only levitates at a certain exact temperature, and boop, it pops up in the air. Because it's sucking the electrons off of that thing so fast, it turns into a positive mass, and it elevates, pushing positive against the Earth. That is anti-gravity. I got a whole lot to talk about this, but anyway, these are either electrons, extra electrons, or they're pushed up into orbitals, and I think they can be crushed into lower orbitals, and they can be expanded into upper orbitals, and they can be literally pushed away from, and the actual molecule itself is expanding. Then there's another thing that comes into effect is atomic shock. We have compressed gases and hydrogen. You can actually explode those by hitting them with a ball-peen hammer if you're not careful. It's called atomic shock. I have a couple of videos on that. I did extensive look into that because of the compressed gas industry. And they came up with the ruling that there was no ignition source. And it's a spontaneous combustion type, not combustion, but it's a spontaneous atomic explosion, literally, from atomic shock. When you and you know, you're talking hydrogen and stuff like that, very, very explosive molecule, element. Anyway, we're going to go through all of this stuff, I guess, at some point. But my mind's cooked for this today, and I'm sure yours is too. So, remember, everything is nothing more than electrons moving. And electrons moving is light and it's heat and they're shaking actually as sound. I mean, it's everything is vibration. Tesla was right, and the ancients were right. Ether is nothing more than electrons in transit from their source, whatever that source is. They might be floating around the earth, they might be just sitting idly, or they might be spewing from something. But they are the essence of the entire universe, is ether. That's what creates some polar fields, the magnetic fields, the aurora borealis, which everything. It's Tesla was right. So, Mud Fossil University, the Citadel of Truth.